Okay, so for this problem, we have a hemisphere. Okay, Maria wants to determine the volume of a hemisphere-shaped dome found in the SM wall of Asia. So given that the surface area of the dome is 987 meters squared, find the value of x, the radius, and the volume of the dome. So first, we're given here the surface area, okay, of the dome is 987 meters squared. And we know that the surface area for a hemisphere, the formula for that is 3 pi r squared. Okay, so we got the 3 from dividing a whole sphere by 2 and then adding the base there, the circular base at the bottom, so you get 3 pi r squared. So from this formula, we can substitute the value of r, which is 9x plus 4, into this formula. So we get that the surface area, which is 987, is equal to 3 pi r squared. So it's r 9x plus 4 squared. So if we square 9x plus 4, okay, we get 81, okay, 81x squared plus 72x plus 16. That's equal to 987. And simplifying, we get, okay, so we get this expression 267 pi x squared plus 216 pi x plus 48 pi. And then we transfer or we transpose 987 to the other side, so we get 0 is equal to 267 pi x squared plus 216 pi plus 48 pi minus 987. And using our scientific calculator, we can find the variables or the values, okay, for the roots, the two roots of this quadratic equation, since it's an x squared. Okay, so we can use our calculator here. And the value of x sub 1 and x sub 2 is, okay, so using the steps, guys, that I taught you on finding the roots of a quadratic and a cubic equation using a scientific calculator for a Casio 9 FX991ES Plus calculator, you can get that the root. Okay, so the roots are 0.67 and negative 1.48. And since we cannot have a negative root, we will only use the positive root, which is x plus x sub 1 is equal to 0.67. Okay, so that's going to be x is equal to 0.67, and therefore we can solve for the value of r. Okay, so we have the radius is equal to 9x plus 4, and then we substitute the value of x of that, which is 0.67, and we get that the radius is equal to 10.03 meters. Okay, so that's the radius of the dome on the problem on the SM wall of Asia, okay, for the dome. And then we need to solve for the volume of the dome, so we just simply use the formula for the volume, for finding the volume of a hemisphere, which is 2/3 pi r cubed, and we substitute the value of r there, which is 10.03, and we get, okay, so the volume is 2113.30 metric cube. Okay, so that's the volume, this is the value of the radius, and we got the value of x, which is 0.67. Now we go to another problem, a hollow cylinder. So it's kind of shaped like a tube. Okay, so Marcus wants to determine the surface area of a small tube shaped like a hollow cylinder, shown on the image on the right. So the dimensions of the tube are given on the illustration. Given that the volume of the tube, okay, so the volume is 2,500 cubic centimeter of this hollow cylinder or the small tube. So we need to find the value of the small r, which is the radius of the small circle, okay, the big R, which is the radius of the big circle, okay, small circle, big circle, and h is the height of the hollow cylinder or the tube. Okay, and then we want to know the surface area, okay, surface area of the small tube. Okay, so first what we're going to do here, we have to use the volume formula for finding the volume of a hollow cylinder. So that's V is equal to pi h times the radius of the big circle squared minus the radius of the small circle squared. So that's going to be V is equal to 2,500, okay, is equal to pi times h, so it's the value of h, that's 2x minus 12, okay, given on our figure here, 2x minus 12, and then we have to multiply that to r squared. So what's big R? So big R is x plus 12. Okay, so this is squaring a binomial again. X plus 12 squared minus x minus 3 squared. So that's again another squaring of a binomial. And if we simplify this, we get 2500 is equal to 2 pi x minus 12 pi when we distributed pi, and then multiplied by x squared plus 24x plus 144 minus x squared minus 6x plus 9, and that will give you, okay, so that will give you the product of 2 pi x minus 12 pi, okay, and 30x minus 135. So this was the simplified form of the values that we have here. Okay, and then if we get the product of these two, it's two binomial, we'll get a trinomial, so that will be 60 pi x squared minus 90 pi x minus 1620 pi, or 1620 pi. And if we transpose 2500, we get 0 to solve for the value of x, so this will be 60 pi x squared minus 90 pi x, okay, minus 1620 pi, or 1620 pi, minus 2500. And again, using the calculators, or using your scientific calculator, you can solve for the quadratic roots of this equation, and then you get, okay, so we get that the roots is equal to 7, the first root is equal to 7.14, and the second root will be equal to negative 5.64 if you use your scientific calculator. And since again we can't use a negative root, we're going to use the positive root, so x sub 1, or the value of x right here that we need to substitute, should be equal to 7.14. And if you substitute that for small r, the radius of the small circle, big R, the radius of the big circle, and the height, you get 7.14 minus 3, so you get 4.14 centimeters. 7.14 plus 12, you get 9.14 centimeters for the radius of the big circle. And 2 times 7.14 minus 12 is equal to 2.28 centimeters. So this is the height of the hollow cylinder. And these are our values, okay? And we need to solve for the surface area of the cylinder that we have here. So we have here the formula for finding the surface area of a hollow cylinder or any kind of tube. Okay, so a three-dimensional figure, so that's 2 pi h multiplied by the difference of the bigger circle's radius and the smaller circle's radius, plus 2 pi times the radius of the big circle minus the radius of the small circle. And again, we derived that formula from our previous video. So we substitute the value for h and big R, and then small r, and again for big R and small r. And if we compute all of that, the value of the surface area of the hollow cylinder is equal to, okay, so the surface area is equal to 309.13 centimeters square if we evaluate that. So we found the radius of the big circle, the small circle, the height, and the surface area, and also the value of x, which is 7.14. And then we have here a tetrahedron problem. So we're now on the realm of Platonic solids. So Rhea wants to build a doghouse for his aspin, okay, asong Pinoy named Doggy. Okay, so Doggy's doghouse is in the shape of a tetrahedron, shown on the image on the right. Given that its surface area is equal to 52 meters squared, find the value of the side A, the value of m on the side, and the volume of the tetrahedron-shaped pet house. Okay, so again we have here a tetrahedron, 4 congruent triangular faces, and this is the pet house of an aspin of an asong Pinoy called Doggy. Okay, so we want to find the solution for this problem. We want to find the measurement of the side and the value of m and the volume of the tetrahedron-shaped pet house. Okay, so we know that the surface area, okay, so the surface area of a tetrahedron is equal to square root of 3 times a squared. Now we know that the surface area is 52, right? So we just write here 52 is equal to the square root of, so you need to multiply a, so the value of a is 9m plus 1, so we just simply square this entire term here, this entire algebraic expression, so 9m plus 1. So we get 52 is equal to square root of 3 times, so that's going to be 81m squared plus 18m plus 1. Okay. And then from here we can distribute the square root sign. So that's going to be 52 is equal to 81 square root of 3. Okay. 81 square root of 3 m squared plus 18 square root of 3 m plus square root of 3. And from here we can now solve for the value of m by transposing 52 to the other side. Okay, so that will be 0 is equal to 81 square root of 3m squared plus 18 square root of 3m plus square root of 3 minus 52. Okay. And from there, again, you can use your calculator to solve for the roots of m, and that will be m sub 1 and m sub 2 will be equal to 0.50 and negative 0.72. Now we cannot use negative 0.72 as the value for m because it's a negative root. Okay, so we're going to have to use the positive one. So m is equal to 0.50, and that's what we substitute here. So a is equal to 9 times m plus 1, and we all know that the value of m is equal to 0.50. Okay, and then plus 1. So that's going to be 4.5 plus 1. And that means the side measurement, the congruent side measurements of this tetrahedron is equal to 5.5. Okay, let's check our units, meters. Okay, so that's the side measurement. And now we want to know the volume of the tetrahedron. Okay, so the volume, for finding the volume of a tetrahedron, we have the formula a cubed all over 6 times the square root of 2. And if we substitute the value of a for that, for 5.5 for a, so we get 5.5 cubed all over 6 square root of 2, and that will be equal to, okay, so the volume will be equal to 19.61 metric cube or cubic meters. So this is the volume of the tetrahedron shaped pet house or dog house for doggy, the asong Pinoy. Okay, for our second Platonic solid, we have here a hexahedron or cube. So the most common or the more common term that we usually use for a hexahedron is a cube. 6 equal square faces. Okay, so Roark is planning to build a cube-shaped room for the stray pets that they have adopted around their community, most of which were cats. So the cube-shaped room has lots of windows for the pets to see through the outside. So the volume of the cube-shaped pet room is 1,400 metric cube. And Roark wants to find the surface area of the room, the side measurement of the room, and how many boxes he could fit inside of the room given that each cube-shaped box is 3 meters long. Okay, so he wants to find 3 things. So the first one is he wants to find the surface area. Now we're given here the volume, and we all know that the volume of a cube is s cubed. Okay, and we're given here the value of s, which is 2x plus 1. So we just simply cube that. 2x plus 1. And we're also given the volume of the cube, which is 1,404. Okay, and from here we can cube this binomial, and its cube is 8x cubed plus 12x squared plus 6x plus 1. And then from there we transpose 1404, or we transfer it to the other side through addition property of equality. We get 0 is equal to 8x cubed plus 12x squared plus 6x plus 1 6x plus 1, and then minus 1404. Okay, so that's going to be negative 1403 or 1,403. And from here we can use our calculator. Okay, we can use our calculator to get the 3 roots of our cubic equation right here, and those again we can use the steps that I've taught you guys, and the value of the 3 roots are, okay, so we have here our roots 5.10 and negative 3.30 plus or minus 4.85i. And again, we cannot have complex roots or negative roots, so we're going to use x as 5.10. From there, we can find the measurement of the side. So it's going to be 5.1, okay, so 5.10 or 5.1, okay, times, okay, plus 1. 2 times 5.1 plus 1, so that's going to be 10.2 or 10.20 plus 1. So the side measurement is going to be, okay, 11.20 meters. So substituting the value of 11.2 to us here, so we get 6 times 11.20 squared to get the surface area, and that will be 125.44. If you square it and you multiply it to 6, you get